Okay, so basically, I call this structure governs function, and it's it's kind of become a cliche in osteopathic circles now at this stage. My background is in amatsu, which is a form of Japanese osteopathy. Uh, Strictly speaking, it's a form of Japanese folk medicine that was passed down through many generations. But the closest thing you'll find in the West to it is osteopathy. It shares points in commonality with things like craniosacral and cranial osteopathy as well. Um, so I thought a nice point of departure was structure governs function because it's so succinct and it really helps you understand. And and when you start to look into it, it becomes it's so stupidly obvious. Like I mean, uh,
To
I
you,
could
maybe.
to me maybe like hopefully to everyone by the end of it. But if I like just start with a really stupid example, I could have chosen anything randomly in the room. But if I take a cup, right, the function of a cup is that it has to hold liquid that I can drink out of. So just and ideally I should like there's warm liquid, so it's going to have a handle so I don't burn my hand. So I'm holding the cup here. It's got liquid in here. It doesn't leak out. It's designed in such a way that I can drink out of it. So the structure of the cup, the function and the structure are intimately related on a cup. So it's kind of you know it's like pointing out the obvious. Um, if I've got a hand, you know, uh, we're the only creature that can do this. By the way, this is our precision grip. Monkeys have a precision grip that just does that. We can approximate each finger individually. Uh, in evolutionary terms, that allowed us to make tools. But you see, there's a structure to a hand that allows it to function in a certain way to do things for us. Does that make sense?
Yeah.
Okay. Um, and so there's a structure to the whole body. So if you think of, uh, say, let's take a random organ, for example. You've got the lungs. You've got the trachea that comes down with the rings of cartilage around. Then that separates into the bronchi and the bronchioles, finishes off in the alveoli, the little sacs. They fill up with air. There's interchange of oxygen, passes out of the alveoli, diffuse into the bloodstream, oxygen into the bloodstream, and then goes into the body uh, to get oxygen to all the different organs. But the structure of the lung is perfect for the function it has to fulfill. So your breathing goes down the trachea into the bronchi, the bronchioles. Uh, that air fills into the alveoli, oxygen diffusion, and so you oxygenate your tissues for work. Basically, the all part of the respiratory cycle. Does that make sense?
Yes, yes.
So and so, moreover, uh, the you could look at this. You could look at the structure of one component part, like an alveolar, or you could look at the structure of the whole, or you could even look at the structure of how that lung is sitting within the rib cage. So consider if you have somebody whose work causes them, say they're at a computer all day, their shoulders are rounding off, their chest is caving in, their head is coming forward. Now, and because of this, the diaphragm, which is at the bottom of the lungs, is not able to push down with your inhalation. What might that be doing to somebody if they're holding that posture for years and years and years?
You
Anybody?
wouldn't be able to, you wouldn't be able to breathe properly or anything. You'd be restricted. Everything would be very tight and enclosed.
Yeah.
So you wouldn't
Uh,
have you wouldn't have the capacity of lungs that you would have if you put your shoulders back and sat up straight.
exactly. So that's where you start to appreciate that, like from the macro to the micro level. And you can take this right down to the cellular level, and the macro will influence the micro, by the way. So, uh, like, what do you think if I'm not able to breathe properly? So now you're not getting the same amount of oxygen exchange. You might even have certain tissues in the body that aren't getting as much oxygen as they need. What might happen there, even right down to the cellular level? So
That
the
is,
function.
yeah, the functioning and the oxygen level will be lower, so the energy level will be impacted as well.
Exactly. So the function is not going to, if your structure is compromised in that way, the function can't work as well as it might. Does that make sense?
Yeah, is that okay for everyone? Yeah. Okay, lovely.
So it's that appreciation of the really, really intimate relationship between structure and function forms a huge part of the osteopathic concept. And it's why, as physical therapists, we look at a body and it's like, okay, most people coming into me are going to come in for musculoskeletal problems. So, what brings them to me typically is their back pain or their joint pain or their sports injury or that kind of thing. But I often try to educate people that yes, that's true as well, but you could also come into me if you had asthma. I'm not doing this as a kind of advert for myself, by the way, but I'm just trying to illustrate how uh, you can treat illness and disease through an intervention through structure. Does that make sense?
Yeah, so basically, if I came into you and I have asthma and my posture or my structure isn't great, you would work on improving the structure of the body, like teaching me how to straighten up and breathe properly so that the asthma will be less dominant in my body and you'll be able to
Absolutely.
breathe better and function better.
You'd probably find a rise in energy and all
Yeah.
kinds sequences of things that get better as a result.
Yeah, the results are huge. Like I did go to a breathing a breath work guy because of my asthma, and like that he told me my posture was off, my breathing was off, whatever. And when I did the different exercises and stuff, it made a whole lot of difference.
That's it. That's exactly it. And that's brilliant because I went to a breathwork coach myself, a guy who was into Buteyko and Wim Hof. We did the ice bath. And
Nice.
and his thing was uh, uh, not just about, okay, in normal breathing, you should always be breathing in and out through your nose. There's very specific reasons for that, and we can talk about that as well. Um, Obviously, in if you're doing Wim Hof breathing, your mouth breathing, and that's trying to achieve something different. But what he said to everybody there, he said, okay, if you want to breathe properly, you're going to have to bring your shoulders back, relax. You're going to have to relax, particularly the whole trunk, really relax the body, because what we were used to be taught about posture in schools and so on was to this kind of shoulders back and very rigid posture, which actually um, restricted the diaphragm. And if
Okay.
you anybody does anything studying about breathing, as you breathe, your intercostal muscles allow the ribs to flare out as you breathe in, and the diaphragm pushes down. So the diaphragm it's like a big dome-shaped structure that separates the thoracic cavity from the abdominal cavity there. So when you breathe in, this diaphragm needs to be able to push down. And it should do that. If it can't do that adequately, it's going to restrict your breathing. It's going to do other things as well. Uh, I, I could go down a lot of rabbit holes here, so I'm going to
I
try and
know.
but but I will say this, just as a thing for everyone, do try to abdominal breathe because as you breathe in, the diaphragm will push down, and the organs are tightly packed. So the abdominal organs here are tightly packed into each other, and they have. We'll talk a bit more about fascia later, but they're double bagged in fascia with fluid between, so these serous membranes, and to keep them healthy, they have to keep gliding over each other with the breath. That keeps them healthy and moving, and you need that bit of movement to keep everything going. And that happens through the breath. But if the diaphragm isn't pushing down adequately, they get stuck, they get rigid, the the membranes here became desiccated, like if you imagine two panes of glass with water in between and those air bubbles develop and the vacuum causes them to stick. So it becomes kind of like that. And then you get stuckness of the organ, and that can start to lead down a route that brings you into disease. Does that make
Okay.
sense?
Yeah, that's very interesting. Yeah.
So, so again, and again, here you're looking at the interplay, which is something I really want to talk about, between fascia, movement, structure, because uh, structure governs function, but in order to keep your structure well, it needs to keep moving because it's a moving structure. That's what the body is. It's meant to move. There are times it's meant to be at rest, but it's also meant to move. You can overdo it in either direction. It's possible to be too sedentary, and that we see that a lot in modern life because people are sitting in front of desks all day and then sitting in front of a TV in the evening. It's also possible to be too active. You probably see this less, but you'll see it in very high achievers who are into sport, actually can overdo it and actually end up causing damage. So there does have to be a balance, but movement is important. Does that make sense?
Yeah. Yeah. Very good. Yeah. Yeah. I think that mostly in this group it would be the lack of movement. Unfortunately, people are very fatigued and find it a huge effort to even think about going and doing exercise, or not even exercise, just movement. You know.
Well, here's the thing. Uh, we you'd still see it out in the culture. There's an idea of no pain, no gain. So it's this idea that unless I'm kind of sweating and all my muscles are aching, I haven't really done anything. Not necessarily true. Um, Taking a walk around the block is a good thing to do. Actually, walking is one of the most underappreciated forms of exercise. People don't realize how much it does for you. When you walk, every single muscle in the body gets activated.
Oh, very good. Yeah, because they make you feel like the famous day, make you feel like, if you're not doing cardio, which there's no hope in hell of us doing cardio, you're going to pay for it. But I think myself, I do a little bit of qigong, and some days I'd only do about 2 minutes. Another day I might do 5 or 7 minutes. Another day I might do 10 minutes, depending on how I feel. But that alone, that's actually as effective as cardio. Am I right in saying that?
Uh, it's as effective as cardio. It
You're
depends.
wrong, am I?
It What I would say to you is it depends on this. It's like I say, it's possible to do too much. You have to tailor it to what you're able to do and what so that you don't damage yourself. That's the most important thing. If you're starting to do something that's actually ultimately causing you harm, then it becomes counterproductive. So
Yeah.
we don't want that. Uh, Cardio, yeah, I mean, it depends on how fit you want to be. I mean, you you could be very fit and do 5K runs every day. You might not be able for that, but you do what you're able just to keep that body moving.
Yeah, there's definitely no cardio happening with ME. It's an
Yes.
extra exercise intolerant condition, so there's no cardio happening basically.
No. But as I say, even a walk is plenty. I mean, like what the the teacher I went to in Japan who taught me the Amatsu form of osteopathy. He often said he now again it's a long. He recommended walking 2 hours a day. Now I understand that not everybody can do that, but walking a little bit every day is hugely helpful.
Yeah,
Uh,
even just walking gently around the garden and getting a bit of movement in that way
yeah,
is still good for you, like.
absolutely. Things like qigong, tai chi, yoga, all of those things, they're soft, slow exercises that really anyone can do, but they'll keep your body well.
Yeah.
The nice trade-off with things like that is uh, for the effort is more mental than physical, actually, with Tai Chi and
Yeah.
Qigong.
Yeah.
It's more of a mental kind of learning the form and cultivating the internal feeling. That takes concentration. In terms of what you're doing, the amount of work you're doing physically, it's not that much. But in terms of the physical movement, does do an awful lot for your body.
Yeah. It is very powerful, isn't it?
Yeah, it is. It is. And if you understand now, jumping slightly into the area of classic Chinese medicine, uh, I there's a form of qigong that I do that's five element qigong. So Sarah, you know Dai, and he's into Chinese medicine, and he'll talk about the different elements and so on. But each form that you study relates to an element and two organs. So there's a
Okay.
form one form of qigong that we do. I was teaching it this morning. One form relates to metal element in Chinese medicine, and that relates to lung and large intestine. And it's on the face of it, it's kind of like, well, why would these movements activate those organs? But it actually works out to be true, and oddly enough, it does actually pan out. They,
Yeah. 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 Yeah.
I'm talking about people who have made a study of this for centuries in classic Chinese medicine, acupuncture, herbalism, and they devised these sets of exercises that specifically work with different organs.
It is. That's actually fascinating now because I never even thought of that. Because when you move a certain way, you will have an effect on the lungs and the kidneys and stuff like that. Or that's interesting. Yeah, very good, very good.
So the specific type of movement will do that. Um, so uh, where do I want to go from here? Um, yes, so we're talking a lot about movement, and we're talking a lot about structure, and it's, again, and then we're talking about function. Structure. If you're not moving enough, that can be problematic, and if you're moving too much, you'll tire the body out, and that can be problematic. Um, What's amazing with the human body is it has its own self-healing modality. The body wants to maintain homeostasis. Does that make sense?
Yeah, it's how to get it to do that is what we want to know because we'd love our bodies to sort themselves out rapido, like
Yeah. Well, here's the thing. Um, the there's an intelligence in your tissues. It's not the intelligence of you thinking stuff through. There's an innate intelligence in there. It kind of knows what it needs. Now, in the work I do, I'm working with that all the time. When I place my hands on somebody's body, uh, as soon as I connect in, and I'll talk more about fascia in a minute, what I'm really connecting in with is the fascial network. So the fascia, there's nowhere in the body that there's no fascia. The fascia is that thing in the body that's in touch with everything else. So fascia wraps around bone, fascia wraps around muscle and individual muscle fibers, fascia wraps around nerve fibers, there's fascia in your brain, it wraps around your organs, it's everywhere.
it's like a
It's the
little
most,
spider's web, is it? Kind of wrapping around everything.
it's exactly that. If you look in the notes I sent you, there's uh, I found a nice picture there. There's a microscopic picture of fascia. You'll see it. It looks like webs with little beads of water interlaced with it. I don't know if you
Yeah,
can
you'll
see it.
all get those notes in your emails afterwards.
Yeah.
So you can have a
So
look at
that
it, but you'll know it's the spider. I always call it the spider web. It
it's
wraps
an
around everywhere and it's
now,
fabulous.
now it's enormously interesting stuff. And the weird thing is, you go back to the say the 1500s, and you had all these. It was the age of enlightenment in Europe, and people were starting to study empirically sciences. And people were getting into anatomy, so they were dissecting corpses, and it's a bit gruesome, but it's how they learned. And they mapped the body. They mapped the anatomy of the body, and that's where it all started in the Western world, at any rate. And what they used to do is they'd look at all this connective tissue, the sheets of fascia and the ligaments and stuff, and they'd throw that away because what they were really interested in was the muscle or the organ or whatever. And that persisted in thinking for a very long time. And it's really only in the last few decades that just a realization that fascia is no, it's not this inert, rubbery stuff that just kind of twangs things together for a bit, and don't worry about that too much. It's hugely intelligent. It's alive. The collagen fibers, and it does hyaluronic acid in there that allows the structures to glide. It needs to be properly hydrated, so make sure you drink lots of water. That's one way of maintaining your structure. Um, but um, the fascia has its own intelligence, and if you it wants to get back to what's called dynamic balance, and it'll take advantage of whatever you can give it, and you can work intelligently with it. That's what we do as physical therapists. That's what a well-trained osteopath is doing. You're not just rubbing a muscle to stretch it out, or that kind of thing. You're actually putting vectors of force through the fascial net so that it starts to respond and move towards correction. Does that make sense?
Okay, okay. Right. So you're helping it to fix itself so the body gets balanced.
Exactly. And there are specific points that you can work on the body that will facilitate that. There's areas that are really good to go to, that are pattern setters for the whole body. And if you get the fascia to realign there, the whole body will drop back into place for you.
Oh, that's pretty cool.
Yeah, so it's like now, talk a bit about acupuncture. When the acupuncturist sticks there's really interesting research mapping the acupoints to the energy system and the fascial net at the moment, because the fascia is piezoelectric. What
I
that
was going to ask
means,
actually, is there kind of a feeling with the fascia? Can you feel a tingling with it or any?
subjectively, all kinds of things come up. Fascia is also the most innervated tissue in your body. There's loads of nerve endings landing in fascia, so
Yeah, that's
it's
what I was
work.
wondering. Yeah.
It's working very much in tandem with your nervous system. Although, interestingly enough, it has a biofeedback loop that's older than the nervous system, and I'm going to tell you what that is now. Actually, fascia has what's called piezoelectricity. So any kind of tension, stretch, or whatever on it generates an electrical current, which, by the way, works better if it's properly hydrated, because it's semi-conducting and the water helps. Does that make sense?
Yeah, yeah. It helps it to kind of be flexible.
Yes, it helps it be flexible. It helps it to be responsive.
Okay.
So
Does it get dehydrated and stiff? Like
it does.
if you
It gets
don't?
the Yeah, that's why hydration is so important. We need to keep hydrated. It's it's one of the most. It's a thing that a lot of people overlook a lot. And uh, some of you may know I'm half Tunisian, so I lived in Tunisia as a child, and out there it's very hot, so you're drinking water all day long because you are getting thirsty. In this part of the world, I've actually met people who don't like the taste of water,
Yeah, I've met those too. Yeah,
and
yeah.
it kind of puzzles me because I'm kind of going, well, um, there's nothing particularly offensive about the taste of water. I just don't understand it. But there it
Yeah,
is. I
yeah,
I knew
yeah.
somebody who had to put cordial in his water just to be able to drink it.
Right, right.
A client of mine years ago. So I don't know, but in any case, we need to keep hydrated because that's firstly it allows the layers of fascia to glide over each other, but it also allows the fascia to communicate with itself.
Lovely. Yeah, yeah, that's good. That makes sense. All right, yeah.
Uh, and so this idea, uh, if you think in evolutionary terms, uh, if you go back to the a singular cellular organism, Right? So there's no nervous system in there. It's just uh, some of you I might be giving people nightmares going back to school biology, but if you recall the structure of a cell, it's got its membrane with the phospholipid bilayer. So the the hydrophobic bits on the inside and it's the way around. It's the hydrophobic bits on the outside and the hydrophilic bits on the inside. Anyway, it's phosphate and lipids. And then you have inside the cell, you have the organelles. So you've got the nucleus of the cell with all the DNA. You've got the mitochondria. That's what produces all the energy in the cell. That's where the oxygen eventually ends up and gets through a set of chemical reactions produces energy for you. So that's how you start to do work.
And that's where we have our problems with the mitochondria aren't functioning properly, so the energy isn't producing.
Isn't working as well as it might. Yeah.
Yeah.
Um, Now, if you think of a cell, what I was taught is you've got a cell, you've got this kind of blob of jelly inside, and these organelles that are just floating inside it. And for years, that's how I thought of a cell, but it's not like that. There are collagen fibers in there that act like a cytoskeleton that actually hold quite a strong structure in there, and it's a very deliberate structure that's been held in the cell. And moreover, that matrix of a cytoskeleton communicates through the cell membrane into the outside environment. Does that make sense?
Yeah.
So
So the what's in the cell, the nucleus and all that, for that to be functioning properly and it'll affect what's going on outside in the body. Is that what
yes,
you're saying?
yeah. Well, what I'm saying is, there's inside of your cell, there's what's called a cytoskeleton. So the fibers of fascia that are holding things in a very definite shape,
Yeah.
and those fibers uh, extend through the membrane, so they poke out the membrane and they interact with the outside environment.
Okay. Okay.
So
Okay.
now, so try to get that picture. So you have a cell, organelles inside, a cytoskeleton of fascia extending beyond the cell and interacting with the environment outside of the cell.
Okay. Okay.
So now think of your little cell in your primordial pool of life millions of years ago, and it's wandering around doing its thing, and it kind of goes. It needs food, and it needs to keep itself safe. And how it does it is through these projections, through the membrane that kind of go food over here, danger over here, move away.
Right.
But there's no nervous system in here. It's communicating through that cytoskeleton.
Right.
Do you see what I'm saying?
Yeah, so the little bits that are coming out, it's
Yes,
communicating with the rest of the body through those, is it?
exactly.
Okay.
So So you could take an undifferentiated stem cell and stick it like in a baby. They've done experiments like this. You could take a stem cell from the lungs and stick it to the liver, and it'll turn into a liver cell because it's responding to the environment that it's in. So that's
Okay.
that's another side because it's through those projections, it's interacting with its outside environment. Where you stick a cell will depend on what it becomes because the DNA for everything is there. It'll just use that one bit of DNA to become what it wants to become in that environment. But that's inside of a global organism, a single cellular organism. It it moves away from danger and moves towards food. And,
Right.
but there's no nervous system in there doing it the way we have a nervous system, hormonal system, all these complex systems in our body for higher functioning organisms. All it has is its cytoplasmic skeleton, the cytoskeleton in there, which is made of what? Fascia.
Okay. So what you eat obviously is very important. Like they say,
What
like talking about people who don't eat enough, say, they're not feeding their body enough. So basically that will deteriorate the function of the cell.
of yes, anything you take will deteriorate the yeah. Correct diet is so important.
Correct diet, yeah, as opposed to bad diet, yeah, yeah. So
We want
everything you eat has an effect on your cells.
Absolutely, and you need the right proportions of you need your protein, all your major food groups. Uh, in our culture and society, we overdo it. We overdo it with two things. We actually overdo it with protein, as, but we do need a bit of protein.
Yeah,
We overdo it with simple carbs as well.
yeah.
So if you
And
we're, we're, we're,
sweets and processed foods, we really
yeah,
overdo it.
yeah. We're really jumping off a whole other tangent here, but I'm going to talk about this because it's important. Uh, so if you think about uh, the span of human evolution, when modern humans first appeared, we reckon about 200,000 years.
Mm,
So 200,000 years you have people, and for most of that time, we lived in extended family hunter-gatherer groups, and we were nomadic because you deplete food in one area, you'd have to go somewhere else where there's food because you're not into farming or any of that. So you have to keep moving on. That's how we lived. For most of human existence was like that, by the way. About 10,000 years ago, we developed farming. And for a long time we're Stone Age farmers. We're living in little communities, and then eventually those little communities become cities, and then those cities become civilizations, and then we end up where we are today. But that's only in the last 10,000 years. So if you think, for 190,000 years we were hunter-gatherers. For the last 10,000 years we were farmers, and then for the last 300 years we lived in the industrial age. So
yeah,
think about how short that is compared to how long we've been here.
yeah,
It's a spit in the wind. Now, we have this body, so we're in a roundabout way, we're going back to what I'm talking about. We have this body that was supposed to be a hunter-gatherer body. It was supposed to kind of climb trees and run around in the savannah and swim and hunt animals and look for scavenge for bits to eat and stuff like that. Our body is still kind of adapted for that. That's kind of what we kind of are adapted for. And what do we do? We're sitting at a desk 8 hours a day and then watching TV in the evening. And your body is going, what the hell's going on?
yeah, yeah, yeah. And that's where all the disease comes in. Like, I mean, Dee would talk about there was never anything like asthma before,
Modern
um,
is very much
modern, yeah, and even all
modern.
these different things like the irritable bowel and all those, they all came from the breads being changed and all the rest of it, the food being processed and additives and all that kind of thing. Whereas there's
Exactly.
none of that before. You killed an animal, you chopped him up, and you put him on the fire, and it was very clean food. Like, whereas now we're pumping stuff into our food and we're wrapping it in plastic and
Exactly.
blah blah
Yeah.
blah.
We are like so now the good news is you can mitigate those effects because there's a trade-off. I mean, we have a more comfortable life. We're not surrounded by potential dangers and predators, and we don't have to worry about food scarcity, so we have a trade-off there. But we need to mind ourselves, and we need to understand that we are still physically no different to those hunter-gatherers that we descend from. We're the exact same: brain, mind, everything. We're the same as those people. Does
Yeah,
that make
yeah,
sense?
yeah. It does. Yeah, we just live a whole different life.
Exactly. So, so that's gone round all around the earth. Actually, what were we talking? I'm gonna try and bring us back to topic a little bit. So,
Okay. Okay. But it
so
is interesting. It gives you an over helicopter view of where we've been and where we've come to, and
yeah.
that's quite an important thing to know. Like, you
Yeah.
know.
So you talked about diet. Like, it's very interesting now. People are talking more about the paleo diet, and I think it has a lot of value. And the idea is you're taking a little bit of protein, not too much. You can overdo it, and if you overdo it, you can actually the kidneys can have a hard time dealing with it. Um, very little carbs because that's the thing. When we became farmers, the easiest thing to farm was grain because it's easy to store. So you had the granaries where some cultures did wheat or bulgur, or in Far Eastern cultures they had rice, and it's an easy food source to maintain and contain. Uh, but until the development of farming, we weren't really grain eaters. We would have eaten more leafy stuff. We might have eaten fruit. We might have eaten roots. Grain probably a lot less so. I mean, if you think prior to the invention of cooking, for example, it'd be very hard to eat and digest the grains of rice.
Yeah, very hard, very uncomfortable and unpleasant. Yeah,
So,
yeah.
so you're probably not going to be looking at rice and go, "Oh, I'll eat that." You're looking at an apple,
No,
or
no, no, no.
you're looking at a fish in a stream, or something like that. You know. So so the paleo diet talks about reducing grain and going more for a lot of legumes, kind of leafy vegetables, and good quality protein. So you're talking, I favor fish and eggs and stuff like that more than anything. I tend to think that's better source of proteins.
Yeah, yeah.
But
Eggs are very, very pure source of
yeah,
protein. There's nothing in them. They're pure, pure. There's nothing you to fear in them, basically.
yeah, exactly. Yeah,
Now
yeah.
hang on a minute now. Can you talk about proper breathing, more about proper breathing?
Proper breathing. Yes. So when myself and Sarah Lee are actually doing a course with Patrick McKeown at the moment on breath work and the Buteyko method. Essentially, when you're breathing, you want to breathe in and out through your nose and breathe kind of soft and gentle. So it's not a forced breath. It shouldn't feel stressful, shouldn't feel your shoulders tightening up. So it's a nice, soft, easy breath, but a full breath down to the abdomen. So you just, and it'll feel quite nice as you do it. You'll actually find that you become calmer. It actually stimulates the vagus nerve, and you actually go into a calm state with that kind of breathing. Um, that's it. But the other thing, as a motivator, breathing through your nose. Uh, when you breathe through your nose, you produce nitric oxide. And nitric oxide ends up lining the blood vessels, and turns your blood vessels into Teflon, so you get better circulation.
Oh,
So
very
one of
good.
the upshots of breathing properly is that your blood vessels become better.
Oh,
They
that's good.
you actually end up with better circulation. That's
Oh,
why.
that's very good. Yeah, yeah, yeah. Because I have a sister at the moment who's just newly diagnosed with asthma, and I told her 2 years ago to go to a breath guy, a breath technician or a breath coach or whatever you want to call him. And it's only now she's going to go to him because she's been diagnosed. Because she was told years ago she wasn't. Her mother-in-law is very in tune with things. Was very in tune with things when she was alive, and she told her, "You're not breathing properly." And of course, my sister didn't listen to her, so she never did anything about it. And now it's actually got to the stage where she has to take inhalers and stuff like that. Um,
With breathing, like I mean, watch her structurally, just see if there's a bit of that going on, because there might be.
yeah.
Uh, Look at the emotional states as well, because that can play. That can
That's where it's hitting. Yeah, that's where it's hitting because she has a bit of a problem with one of her sons and stuff. So she does swimming, so I think her structure is fine. So
structure is
she
good.
does a lot of
Yeah.
swimming. I think it's the emotional side that's hitting her. Right.
So
Yeah.
so
Yeah.
I remember years ago. I was on a Namatsu workshop actually. One of my main teachers, a guy called Dennis Bartram, came over from England to give us a workshop, and he said I'd always stayed with me because I'd had asthma as a child, and it's true for what I'm about to say was sort of true for me. He said, with asthma, look for an overprotective parent, and I thought that
Okay.
was so interesting.
She definitely didn't have overprotective parents, to be
Okay,
honest
well,
about it.
Well, it could be one of your caregivers because in my case it wasn't my parents, but it was my grandmother was overprotective.
Okay, right, right. No, we never had anybody overprotecting us or whatever. We kind of we had a very a free kind of an upbringing. To be honest, my mother was kind of very relaxed and stuff, and didn't kind of bother too much with overprotectiveness. But
But
yeah,
it
it's
sounds to me like your sister's asthma is a fairly new phenomenon, so probably not something that came out of childhood. So that's
yeah, yeah.
it's different.
Um,
I would probably think that there's from what you're telling me, it sounds like there's an emotional trigger. And just to bring us back to topic, actually a little bit, emotions will affect your fascia. By the way,
yeah, somebody asked here points on body for to help your fascia. Is there things you can do to help your fascia to be
actually,
more?
it segues quite nicely into this. Actually, I'm going to do this with you now because this will show you uh, something very quick and very immediate. I think I did it with you on the day, actually, Sarah, when you were down in.
Limerick, yeah.
So anybody there, if I can't see you, but hopefully, well, you can see me somewhat. What I'd like you to do is just bend to touch your toes, and just make a mental. It's not a competition or anything. Just make a mental note of how far down you can go. So you're not if you can't touch them, you can't touch them. Don't worry about that. Just make a mental note how far down you go to touch your toes. Just as a ballpark. Okay.
Hmm.
So when you've done that, I'll try and get the phone here so you can see. Now, I'm sitting here. So when you've done that, if you just sit up, you're going to grasp your big toe and you're just going to rotate your big toe. I'm just using my hand here. It's nothing particularly complicated or weird. I'm just rotating the big toe. Now what I could do, if you feel dexterous, you can take the other hand and you could massage into the sole of the foot, but it's not crucially important. It can help a little bit as well. But I'm using my thumb here and I'm just kneading into the sole of my foot as I'm rotating the big toe. Now go both directions. So then we'll go to the other side, on the other leg. So once again, just massage, rotate that big toe. In both directions. Okay, very good. So now, all I get you to do is if you stand up again and just go to touch your toes now. Well, the interacting with you, Sarah, but can you feel the difference?
Yeah, I can see a little difference. All right, yeah. I probably have to do it a little bit more to get down to the ground, but I did notice a little bit of a difference.
Now, I don't know if the rest of you did it. I've only got Sarah here that I'm talking to, um, but with some people, it can be. With me, actually, just there, it was quite dramatic. I couldn't touch my toes beforehand. I could have curled my fingers underneath my toes at the end.
Oh, very good. My God. Does anybody want to come in? Do they have an experience with that? That they've a positive experience that they went down further? Yeah, Doreen says she had a positive experience. That's good to see. So, I mean, obviously, the more we do it, like if we did it once a day, say just as a movement, you'd notice the difference over a week. Do you
You'd
know?
notice the difference, and you'd keep that going. Like um, doing it first thing in the morning is quite a nice time to do it. It's just a nice way to it'll limber up your whole body. It's so strange. What I was going to talk about was this is a brilliant demonstration of it. The fascia is completely uh,
Intertwined.
from the tips of your toes to the top of your head. But we really, the fascia is the thing that really makes the body be a single unit. So we, instead of thinking of our body as separate bits, think of your body as one whole thing. Does that make sense? As a see the body as in terms of its wholeness. We we study the body in different, like say, if I want to study anatomy, I might study a liver, I might study the stomach, I might study a bone, I might study, the location of a muscle, its innervation, its shape, what it does, all that kind of thing. We study these things for um, because we separate out and analyze to understand all these different structures, but always understand they form part of a single whole. The body is one thing. It's one indivisible unit of stuff. Does that make sense?
Yeah, yeah, yeah.
So if you say we've often been taught to think of the mind as separate from the body. What we now know is that obviously you've got your brain uh, made up of all these neurons, but the spinal cord comes all the way down to the right down to your sacrum, and then there's the branches of the nerves coming off that innervating your whole body. So would it be true to say that my mind is in my little finger? Because there's a nerve endings here that feed all the way back into my brain.
Yeah.
So I actually think the mind it's not just up here, it's in your mind is in your whole body. And that's a better way to think of it.
It is. It is actually. It's fabulous. Yeah, yeah.
Like if you think in the gut produces certain what's it called? Oh, there are certain neurotransmitters in the gut that only exist in the brain. So we talk about gut intelligence or gut feeling.
Yeah, yeah, yeah.
As an organism, we are uh, a biofeedback mechanism. We're getting feedback all the time, coming back, looping in on itself. We're getting information from the environment through nerve endings coming up into the brain and back down again. So the mind is in the whole body.
Yeah, yeah. It is. Yeah. Absolutely fabulous. Because I mean, if you think about it, if you hit your big toe, belong going, ouch, your brain tells you this hurts, kind of thing, and
And pain can even affect your mood, and it can have a whole sequence of events that you know somebody's walking emotionally. What it does to somebody if they're walking around in pain for days on end, they're probably not going to have a sunny disposition that they would have if that wasn't there.
No, they definitely wouldn't. No, no, no.
So like, yeah, it's that appreciation of the wholeness. But what I love about that little exercise we just did is if you keep doing it, you'll feel that just freeing off your big toe and your whole body frees up. I used to show it to people in yoga classes. I used to call it the yoga cheat. So I'd get people in there. I said, "Do you want to go deeper into your stretches?" And go, "Yeah." So just do this. And the comment I'd get at the end is, "I actually did. Like I didn't think it was going to work, but it did." Like, and but then uh, consider that if your body is more free moving, what effect that might have on your state of mind.
Oh, definitely, definitely. Yeah, yeah. Oh, yeah. Yeah, Catherine was saying there the pain affects your mood. It definitely does. I mean, there's no shadow of a doubt. It definitely does affect your mood. And your mood can affect pain. That's very true. That's very true. Yeah. Because I
Yeah.
mean, if you're going around and you're angry and you're annoyed and you're frustrated and whatever, and everything gets tense, that can affect your body and your mood. Like, whereas if you loosen it all up and you reduce the pain, and that affects your body as well, your mood as well. So
So if you think, actually,
intertwined, isn't it?
here's to give you an illustration of the the connection between your mind, your body, your structure, and your movement. Have you ever noticed the posture that somebody will take if they're depressed?
Yeah. You
So
can see it straight away. Yeah.
and you'll know straight away that somebody happy isn't going to be like this, you know.
Yeah.
And here's the weird thing: it's very hard to be depressed if I'm like this. It's hard to maintain that state of mind.
Yeah. Yeah. Yeah.
But then, like, so you're like this for a long time. Now consider what that's doing to your structure, and then consider what that's doing to your breathing, and now consider how that's even right down to affecting your immune system because you're probably producing stress hormones like cortisol and stuff like that. So all of these things interrelate between mind, between structure, between body, between movement.
Absolutely. Absolutely. And it's great to be aware of all these things. You've really shone a light on all this today,
Yeah,
just to bring it into our awareness and stuff, which is fantastic. I just maybe have a look here and see that I miss anything. Could the lack of water lead to sharp pains?
absolutely.
Probably. Yeah,
Yeah,
yeah. Muscle spasms and stuff. Oh yeah, in soccer they get the if they aren't hydrated, they get the muscle cramps, don't they?
it's so important, and it's not just because, like I said before, the fascial planes glide over each other, and if they're not properly hydrated, they get desiccated. But not only that, the water in the fascia helps it communicate because
Okay.
it's an electrical system and it needs water. It's
Yeah.
If you want to delve deeper, look into a phenomenon called piezoelectricity. Piezoelectricity is where you you put pressure on certain crystalline structures, and it creates a negative and positive charge that actually spreads electrons and will create an electrical charge for you. That's on a crystal, but like certain types of crystals will do that. But inside the body, particularly fascia and even DNA and stuff like that, can be thought, and a lot of the long chains of proteins and stuff can be thought of as liquid crystals, and they exhibit the same kind of characteristics.
Right.
So when you get pressure or tension, you can pull them or compress them, they'll produce an electrical charge, and that's how the fascia communicates with itself through the whole body uh, towards its own adaptability.
Very good, very good. There's a question here. I look forward to being able to touch my toes, Sandra says. Yeah, exactly. The other thing that's probably very important to mention is like you do have to hydrate and whatever, but you have to make sure your electrolytes are topped up as well, because with all that water and releasing it all, um, your salt levels will drop and stuff, and you have to make sure you don't wash out all the nutritional stuff. So electrolytes are very important.
Well, with Dai talking about using, we were the talk there. We were talking about using Himalayan salt and stuff like that. It's also so important and it's full of mineral content as well. That's so good for the whole body.
You have to
So
make sure it's a high quality Himalayan salt.
yeah, yes,
But it's very important, and it's nothing to do with table salt. I mean, they'll tell you don't have salt in your diet, but they mean table salt, right?
it's totally different. Table salt has no mineral content at all. It's chalk and cheese. You're talking about two
Yeah,
very
exactly, exactly. And if you're uncomfortable with salts, even get your electrolytes in through drinks and stuff, as in special drinks that have electrolytes in them. But you can, I mean, literally, it's the same thing. What you make at home will provide you with more nutrition, because you don't know what they're putting into these drinks. Like, so, putting a little bit of salt on your hand and licking it off and drinking a glass of water. It's Himalayan salt you're using. It's the pure pink salt. And so that's
good.
important.
It's actually really good. It's all we use here actually.
Yeah, yeah, it's me too. Yeah, yeah. The guy that was there actually on the day I was with you, there was a shop he told me to go to get my Himalayan salt, and I got it. And I noticed it's much, it's finer, but it's coarser
Yeah.
than it's lovely stuff. You can see the difference. You can feel the difference, I should say. Yeah. Yeah. Any questions, anybody?
So I'll let people go ahead and then I'll talk a little bit.
There's many questions. No, I think we've answered all the questions anyway, so we have a couple of minutes left there if you want to get some points across.
So a couple of things I in the notes there I've given you, I just put from a man named Tom Myers mapped out myofascial lines through the body. Myo means muscle. So his discipline is structural integration, sometimes called Rolfing. It forms a deep tissue massage. And what Tom, I went on a few courses with him, very interesting man. What he did was he mapped out lines of continuity of muscle that forms functional lines through the body. I've just included one in the notes called the superficial back line. You'll see it when you receive the notes, but there are others. And if you want to jump down that rabbit hole, look up Tom Myers and the anatomy trains. But like how he mapped it is so interesting because you'll see it in the notes there that you've got the plantar fascia is continuous with the fascia and the fascia around the heel that becomes continuous with the Achilles tendon. That's continuous with the calf muscles. That becomes continuous with the tendons that wrap in at the back of the knee. They lock into the tendons of the hamstrings muscle. That's continuous with the fascia that overlies the sacrum, up the intrinsic spinal muscles, into the small neck muscles, and right across the aponeurosis that ends up here. And here's the cool thing. Tom said to us, you could have somebody with a restriction in their foot that's giving them headaches.
Yeah, yeah. I always find that fascinating.
I just included that there. It's not the only line in the body, superficial background. There's all kinds of other lines. I just put that in the notes just to give you an example. It just gives you it gives you a nice illustration of how interconnected things are in the body. And does direct kind of structural material connections. There's also connections through neurolymphatic and neurovascular points, and that's a whole other area of study that people in applied kinesiology and different forms of acupressure are into. But you touch something and something will respond quite distal from that area. The other thing, just before we wrap it all up, I wanted to talk about was, oh yes, I'd like everyone just again to really help you appreciate your own structure and biomechanics is this idea of tensegrity. So again, I think you'll see it in the notes there. Tensegrity was a term coined by a man named Buckminster Fuller, who I think he was an architect, and it's basically structures that hold their integrity through a balancing out of forces of tension and compression. And I've got a lovely illustration of one there, but once you get the notes, you'll see it there. But basically, probably one of the simplest tensegrity structures is actually a ball. So if you think of a ball, it's got air inside that's in a state of compression, and it's got the skin on the outside that's in a state of tension. So the air is balanced out with the skin on the outside to create that shape of a ball for you. Does that make sense?
Yeah.
And if I push one bit of the ball, the whole thing displaces. So if I put a lot of pressure here, the ball will displace over here somewhere. Does that make sense?
Yeah, yeah.
Our bodies are the same.
Yeah, because I mean, it is fascinating. That part is fascinating because I mean, it just shows how connected everything is. Like you work on my toe and my shoulder suddenly feels better, kind of thing, you know.
So the way to think of it is this: you've got ligaments on the macro level. You've got ligaments, tendons, and muscles and soft tissue. They're in a, even without tensing a muscle, but they're in a state of natural tension. Then you've got the bones and the incompressible fluids in the body. They're in a state of compression. The compression elements never touch each other. Two bones never really touch each other. They're held in suspension in soft tissue. Does that make sense?
Yeah.
So, for example, a lot of times we think that the body is a skeleton that's stacked into itself, and the skeleton is stacked, and then you got a load of meat dumped on top of it, and that's your body basically. It's not really like that, because if it was like that, I wouldn't be able to do this. I wouldn't be able to put all my weight on this leg and rotate through this hip. Wouldn't be able to do it because this would be so stacked and jammed in there'd be no movement possible here. But there is. And there is because this, as a matter of fact, there are forces pulling the hip out of the joint slightly. So it's balanced. There's a balanced tension in there that's holding it just enough in the joint to hold its structure, but pulling it out so it's not jammed in. Does that make sense?
Yeah. It's fabulous because I mean it's just so I mean it's so intricate, really, isn't it? It's designed. I mean, it's perfectly designed.
Yeah, so then it's just appreciate that the body is not a weight-bearing structure. Now, gravity has an effect on us, and we can align our body to gravity. There are ways of doing that. We talk a lot about in Tai Chi and stuff. You line up your body so it bears the weight of gravity in an effortless way. But our body isn't a weight-bearing structure. Our body distributes weight, and the weight is distributed along the tension elements. So
Okay.
instead of the weight doesn't just do in a column, the weight is spread out through the whole body. And that's what enables me to be able to move in lots of different directions and become multi-directional in my movement.
Right. Yeah.
Does that make sense?
It makes perfect sense. Yeah, absolutely. And I can understand why you're interested in this because it is fascinating, isn't it? Really.
Well, it's a huge area, and I my belief is it's actually one of the areas that as we start to understand more and more about this, it's going to be at the cutting edge of a lot of stuff for people because we're starting to understand now that even different vibrations and sound can affect tissue. So
Yes.
into the
Yes.
area of biophysics and stuff like that, and where that goes, it may go nowhere, but it's worth investigating because the resonance will affects it as well. People do all kinds of weird things with tuning forks and everything now in the body.
Yeah, but even the simple thing of humming and how it affects your vagus nerve, like I mean, I mean that's only one small thing, but I mean if you opened up this can of worms, you could really benefit people hugely.
So so the understanding of um, I I remember asking when I was first getting into Matsu, I was talking to my friend teacher Paul Hand actually years ago, and I said to him, you know, when you do this physical therapy stuff, I mean, sure, you're helping a structure get back into place, and that's great. But will it affect it down to the cellular level? And we were sitting in the car. He was driving me back somewhere at the time, and he's thought about it for a few minutes, and he said, "Yeah, it would, because as you change the structure towards health, as you change that structure towards health, the chemical environment that the cells are in, by necessity, have to change." Because the
Okay.
structure changes, the chemical environment changes, it's becoming more adaptable as well. Even right down to if you change somebody's rib cage, they're breathing better. If they're breathing better, they're getting more oxygen. The chemical environment in the body is changing.
Yeah. It's very powerful stuff, really, isn't it?
So,
I
so
know my energy when I did the breathing work or the breath work, it definitely improved my energy by at least 10%.
yeah, it would.
Oh,
It
it
would have
definitely
to.
did. Yeah, it definitely did.
So, in terms of actually, I should try to bring it back to ME and chronic fatigue. If you can get your structure well, if
Mm.
you if you can get your structure back to a state of dynamic balance, your body's self-healing takes over and helps to your body wants to heal. It's just what it wants to do, and it stands a better chance of doing that if everything is where it's meant to be.
Yes.
So but the other upshot of it is A body that's out of balance structurally is using energy just to stay upright, just to move. It's taking more energy.
Okay.
If that, so you think of an economy of energy, if you think that that energy now isn't being used just to try and hold you up anymore because your structure's way better, that energy will then go into healing, and that energy will go into, well, energy actually, as a matter of fact, you'll have more energy generally because, you know, it's it's a lot more tiring to walk around like this than walk around like this.
Yeah, yeah, yeah.
Because
That
here,
would that would be a huge benefit for us. I mean, because if we are, and we don't know if we are now, but if we're slumping a little bit, we wouldn't notice that other people would. Um, it basically, I mean, any percentage of improvement in our energy is like gold dust.
absolutely. So look, actually, do you know what we'll do? We'll finish up. I wanted to give people this. Does everyone have time for a couple of more minutes?
Are you okay for another 5 minutes? Yeah, good. Okay, all right. This is okay for another 5 minutes.
Okay. So here's what we'll do. I'll get everyone to stand up. I was doing this morning, actually. So what I'd ask you to do is just bring your feet so they're about hip width apart and make sure they're parallel. So they're not pointing out, they're just pointing straight forward. And what I'll ask you to do is just slightly bend your knees and with your coccyx, just tuck it in slightly. Now, not hard, you don't have to, it's not all tension. You just gently just rolling your coccyx in and under so you're not sticking your bum out, basically. So it's like you're just tilting the hips forward a little bit there. That just takes the pressure off your low back. Does that make sense?
Mm-hmm. Yeah.
And then with your shoulders, just have your shoulders directly over your hips. Hold on, let's this a bit further back so you can see me. So, and with my head, what I'm going to do is I'm just going to bring my chin back this way. So I'm not tilting my head back. I'm not looking down. I'm just bringing my chin straight back so that now my neck is directly over my shoulders. So I don't know if you can see there, but my head and neck are directly into my shoulders. My shoulders through my trunk are falling straight into my hips. My hips are aligned up with my knees and my knees are lined up with my feet and into my heels. Can you see that?
Yeah.
That's all it is. Now, once you have that alignment, just let the body relax. Just let everything go. As much as possible. You might find you have to hold it up, but well, if you get this right, you're aligned with gravity, and it actually takes a lot less effort to stay standing because the body is stacking into itself now. Does that make sense?
Yeah.
Now, from there, just start to take deep breaths in and out through your nose down to your abdomen. So you want to, when you breathe in, ideally, you want to feel that area just below your belly button swell up. Okay. Now, what I'll do is just work a little bit on our mind. Just bring your mind into the present moment, which is to say, any of the mental, emotional stuff you've got going on, you might not be able to clear your mind, but you could just not get hung up on any of it. So anytime you find that your mind is drifting off to what you're going to have for lunch or what that person said to you yesterday or whatever, just, yeah, that's interesting. Notice that happen, let it drift by and keep bringing your mind back to this moment. Okay, brilliant. And so from there, what I'll get you to do is, with your mind as a disposition, create a feeling connection with your whole body, as if bringing your mind into your body fully. So if I was to ask you what the little toe on your left foot felt like, you've got direct access to that. It's like, that feels like that. You might not be able to describe it in words, but you have a direct connection. You know where that is, what it feels like, where it is in space, all of that. But try to do that with your whole body. So you have a feeling connection through your whole body, head to toe, left to right, front to back, up and down, and so on. And from there, keep relaxing the body and keep stacking the body into the floor. And breathe in and out to your abdomen through the nose. So and you can keep making adjustments in the hips and the knees and whatever to find that sweet spot where you can let go even more, where there's less and less tension in your body because you're lining up your body with gravity. Now imagine if you were to practice this every day, how that would change your structure, change your breathing, and even change your mind. And it would not be a waste of time to practice this every day, by the way. Can you feel it?
Sure can, yeah.
And that's all it is. We call that body being. There's a few bit more in the notes there, but we talk a lot about um, calm the mind, relax the body, ground the body. We've done all that. You're breathing and moving from your center, and you really think of the whole body as one indivisible unit. Actually, we've talked about all of it today. But if you can bring that to mind as you do this, it's a form of standing meditation. And it's to somebody looking, you could be standing in a queue doing this, nobody'd know any different. You don't look weird doing it, you're just standing there, but you're actually practicing something very profound as you do it.